Nearing the end of the video, we have lighting left to do, sound and post-processing. Lighting is by far the largest part of, bit of that. We can start with that first. First of all, lighting should always be rebuilt using light mesh. You should not turn light mesh off, because it does light mesh does all kinds of important things for mobile, such as the repacking, trying to make square light maps out of it, and it also does better compression than without light mesh. If you turn light mesh off, the compression of the light maps to a more mobile texture format would happen upon save. With light mesh, it will do it during light mesh, provided it's being built on production. So in other words, if you rebuild a level with light mesh on preview, then it would only compress those light maps to PVRTC the moment you save the level, and then the quality of those light maps will be a bit lower than the maximum you can get out of it. For best possible results, you should set it to production and rebuild with production, because production rebuilding includes mobile compression as well, and you will get better results out of that. Other than that, another very major point of lighting on mobile is that it's not high dynamic range. That means that you can have a maximum of 200% brightness on any mobile device. And some of these lights here are a lot more than that. If you open up, for example, this one is set to brightness 8. This is 800% brightness. The maximum allowed on mobile is 200%. And this goes for almost every light in here. This is 8 as well. And this is 0.2. This is 4. It's also too high. So any light you have cannot be higher than 2. So you will have to scale down all of the lights in the scene here to a value under 2. And this also goes for combined lights. So this light is 8. Even if I were to make this 2, if I would have 2 of these lights next to each other, then the combined result of that would still be 400% brightness. And that would still be too much. So no surface can be lit up by more than 200% brightness. If you do lit it up by more than 200% brightness, it will still work, but you will get the following. You would get this, and these are greenings. You can see here the light tends to gets green. This area here, and you can see it here as well, and there as well. It loses the original color and it begins to turn towards green. You see here, very obviously, this begins getting green. That's called a greening because the green lighting channel has a slightly more information available than red or blue. And because it has a little bit more information available than the other two, the brighter it gets, the more pronounced that difference gets, thus the whole thing gets a bit of a green feeling to it. This is a problem for old engines. This is a problem, for example, Unreal Engine 1 had this very pronounced, Unreal Engine 2 had this as well, and now it's back in mobile development. So the only way forward is pretty much just selecting all the lights. For example, I can shift click a property here. I'm shift clicking brightness 8. And because I shift clicked it, it now shows up in the right click menu. So select by property brightness 8. Now I have 12 lights selected that are brightness 8. And I'm now going to make them say 0.75. A bit under 2, so I have a bit of a buffer space left. Like so. And this is what you will have to do for all of the lights here. This is brightness 3, too much as well. So let's say this is 2 then. Brightness 4, that's too much as well. It would get a bit more dull from this, but it's going to be hard to avoid. Say 2 or 1.75. This is 2 already. Got spotlights with 4 here. This is 10 even in the corridor. Etc. You can also see in my final finished level that I've done some more changes to the light in order to get it to look a bit better. So I moved a couple of those lights around. Depends on how it looked on mobile. I think of the lights in the corridor, for example, I increased the radius a bit because now it gets very dark here. So I think I messed around with properties like this as well. But, you can tweak it as it suits you. But the main point is it should not go above 2. Also, mobile has a big problem with dynamic lighting. big problem in the sense of you can't have it at all. So what we have here with the fire, you can see it's animated, the fire is blinking, and it's a point light movable. You cannot have point light movables on mobile. You can only have standard static lights, like a standard point light, a standard skylight, a spotlight, but not dominant lights and not anything that's movable or toggleable. So this light will not appear whatsoever on mobile, both because it has a light function which causes the blinking and because it's movable. So I'm going to have to convert this. So I'll place the new lights next to it. I simply held the L key on the keyboard, clicked on the ground, got myself a new light. And now I'm going to copy over the color from the original. I usually quickly copy color by going into advanced and copying the hex value here. Paste that. If it doesn't automatically update, I usually press alpha, just click it just to make sure it updates, because it doesn't always detect the Ctrl V. There we go, updated. I'm going to say it's 2. Delete that one. Place this one there instead. And the radius seems quite okay. Might want to tweak it a bit, but seems fine. Then also we have the K actors over here. I'll turn off the bounce for a moment again. So these are 2 K actors. The best thing you can do with mobile meshes is to light map them. However, since the K actor might roll through the entire level, it might be moved quite a long distance, you might want to keep the dynamic lighting on these. So K actors do have dynamic lights, but you can't light up the rest of the environment with dynamic lights. You can, however, light up K actors, interp actors, skeletal meshes with a light environment. That does work, and that's what's happening on this right now. The problem then is, however, that the shadow casting they have is going to be very, very bad on mobile. It's both slow and it's simply really ugly. So you can see it's probably kind of hard to see because it's a dark environment here. But right now they have quite a nice dynamic shadow. You can see it nicely fades out as well. It's kind of soft. None of that is going to be present on mobile. What you would get on mobile is a very harshly outlined dark shadow. That's it. It will look very primitive. So because it looks so very primitive, I usually simply turn off cast shadow, because it looks too bad and it takes too much performance for what it does. Another problem with mobile meshes and mobile lighting, dynamic lighting, is that the light environment, and for information on what a light environment is, please refer to my lighting tutorial. But the problem with the light environment on mobile is that it will appear much darker than it will appear on PC. So if I put this on mobile, this is probably going to show up near black. So in order to work around that, what I tend to do, and what I did all the time in a mechanical, is I would give these meshes, I would pretty much give all the characters in the level their own lighting channel. Say for example unnamed 1, something unused, these are unused. So I would assign unnamed 1 to them, take away dynamic, and then I would get a second skylight in. So a skylight simply illuminates the entire level. Gives a bit of an ambient glow to it. It's very low values here, but it just makes sure that nothing is pitch black. Actually, while we're at it, you should prevent pitch black on mobile, because if you use the material hack that I've shown before with an environment map combined with a normal map, if you would get that without any lighting at all on mobile, it would appear very, very shiny. So you always have to make sure there's at least 0.01% brightness available on every single surface. Otherwise it would look very weird. So I have a skylight here to add a small amount of ambient light to the entire scene. So what I can do now is I can duplicate that one. So I did Ctrl C, Ctrl V, or Ctrl W if you want. And I can say brightness 0.5. You can see how the ambient works here. It lights up the entire level. And also there is a lower brightness. I can set it to 0.5 as well. And then I enable unnamed 1. And I take away the other light channels. By doing so, I'm making sure that this light, you can see it, only affects the objects that share the same lighting channels. So now I've made a skylight that only affects K actors. And I can use that to bump up the brightness of these a bit. I'm going to set it to 1 even. Again, to really properly judge this, you should install it on the device and judge how bright it is over there. Because the brightness levels, again, are really quite different. So that I can do this with a K actor. What I can do with my interpactor over here, however, and also we have some interpactors over here as well. What I can do with those, I'm going to select all interpactors. That's 5 of them, 4 wheels plus the door. First of all, they should also not cast a shadow for the same reason. And then secondly, if you can, you should use static lighting on interpactors. It's going to be a lot faster to render. So I don't want dynamic lighting on these meshes because they're below the ground anyway. They don't really move that much, they just rotate a bit. So there's no need for actually having dynamic lighting on those. What I will do instead is I will enable use pre-computed shadows in the static mesh component part, lighting use pre-computed shadows. Enable that, then it goes black, that's fine. And then in lighting channels, it's currently set to dynamic, set it to static instead, because all the lights around it are static, so it should take on the same channel. So static instead, and I'm turning off dynamic. Now it remains black, but if you were to rebuild this, it would show up absolutely perfectly fine, and it's much faster to render. So if you have dynamic meshes like interpactors and K actors, and you can, then you should really consider using pre-computed shadows on those, because it would render a lot faster. If you can't, then you will probably get, then dynamic light environment will work fine, but it will probably appear too dark, so you might want to consider adding a skylight that illuminates just those meshes. And also there is a property here, by the way, while we're at it, that says dynamic. You might want to try to turn that off. If you turn that off, then the light will not get updated all the time. It would only render once and then kind of bake into the model. It's kind of an in-between solution between having a dynamic light environment and light mapping a mesh. It's kind of in between both of them performance-wise. Also talking about light mapping on meshes, all the meshes on mobile must be light mapped. You cannot have vertex lighting on meshes whatsoever. So for example, if I were to do this, if I were to enable override light map resolution, which it already is in this case, but then types 0 in override light map resolution, then it would render vertex lighting on PC, because that's what it falls back on if there is no light map available, or if the light map has been set to size 0. But that vertex lighting on mobile, however, will not work. It will appear very dark, and it's basically simply not going to work. So it's absolutely essential that every single environment mesh, every single static mesh pretty much in your level, has a light map, has correct light map coordinates, and has a resolution higher than 0, or you will run into problems. Have a look at what we did in a mechanical, lighting wise. Here in a mechanical, you can see that all of our lights are under 2. For example, there's a lamp here. This has a brightness 1.97, so pretty much right under 2. This is 0.5, 0.5 again, etc. This goes for all the lights we have. This is 2 exactly. 2 over here as well. There might be slight overlap from these 2 lights, but that pretty much doesn't show up. Plus the light is green as it is, so any greening is kind of masked away, etc. You can also see that all of our interpactors, for example, we have a door here that has been set to use pre-computed shadows, no shadow casting, and static light channel enabled. So we light mapped every single interpactor in the level pretty much. Here we have a K actor. It's a pipe cover you can open up. Same thing there, pre-computed shadow is enabled. Shadow casting is actually enabled on this one. And there's a static lighting channel as well as another one for some specific use. We even did this on our K actors. Here is a K actor, it's a rock you can pick up. Even that one has used pre-computed shadows enabled and cast shadow off. It doesn't run on the static lighting channel, however it runs on its own lighting channel, which is being lit up by a skylight that's somewhere around here. There's a number of skylight here, and some of them affect K actors, others affect the level itself. You can see, for example, this is the one that affects the rock. That way we were able to light up the rocks and all the interactive meshes with a different color or a different brightness. For example, if the testers would say that our K actors are too hard to notice, it's too hard to notice this rock, we would easily be able to say, okay, we want all the K actors to appear brighter then. We can raise the brightness of this specific skylight. So that was the idea behind that. We have a single skeletal mesh here. This thing is a character and a skeletal mesh. Can't light map that. So what we did instead is we turned off cast shadows again, and we turned off dynamic. So it's still a light environment, but at least it renders as fast as it could possibly render. And also we've done some minor optimizations by selecting rocks like these, which are pretty much black. You can't really see them, they're quite on the edge. And we did override light map resolution on them and set the light map resolution to something low, 32 or 64, in order to save some memory. And we did that pretty much true on a lot of rocks in between that are hard to spot. For example, this one is hard to spot. We manually lowered the light map resolution on that one.